I'm going to talk to you today a little bit about our experiences scaling with Laravel. A little bit about me. My name is Seb. Right now, I work at Square. I've been working there for about the past 8 years. Most of that time has been spent working on our online store products. So Square is a financial company. We help people take transactions. Merchants have their physical stores, but if they want an online store, we help them get set up, run their store, and they can take payments online. If you want to find me after the talk, I'm Kepin, K-H-E-P-I-N, on a bunch of internet places. I'll be Twitter, Gmail, GitHub, etc. So, I don't know how many of you have read something like that online, but I've seen this sentiment shared quite a few times, where somebody will come on and say, hey, I have a great idea for an app. This is what I want to build. This is what I want to do. It's going to use this database, and I'm going to use Laravel to run it. And inevitably, someone in the comments will pop up and say, whoa, no. I wouldn't use Laravel for that because it won't scale. So I want to talk a little bit about that today. First, we have to kind of agree together what it means to scale. And usually, when we talk about scale for a Laravel app, we talk about how many HTTP requests are we handling, how many jobs are we running, how many queries to our database, maybe how many servers we have. But as all those things go up and to the right, there's a whole other side that you have to care about as well, which is how many contributors do you have? How do you organize the code for everybody to participate? How do you keep your documentation? Do you have one or many services? Does your deploy process change over time? While those are not the topic of today's talk, those are also extremely important for you to figure out as you scale things up. So, what is it that we're scaling? Everything I'm talking about today is taken from direct experience scaling one of our largest Laravel applications. And what that application does is, like I said, we have the online stores, and today they're served as a single-page application. And we provide with that app the backend API for that application. So that'll be the catalog, giving you all the products that are for sale, the pricing, the inventory, that'll be the locations. We have merchants that operate out of multiple locations. That'll be the fulfillment information. Are you getting things for pickup, for delivery? Is it being shipped to you? Well, that stopped working again. Sorry. And so at the core of this app is an API to retrieve a list of products. That's going to be really annoying if that doesn't work. OK. We knew from the beginning we didn't want the front end to have to do a lot of back and forth with our back end to figure out everything that was related to an item. And so in this case, if, for example, the item had options, if it's a restaurant, maybe toppings for the different dishes, we wanted them to be able to request that be included with every item in the response. And if there's discounts, same thing. Maybe they want to strike out the old price and show that it's discounted for a given amount of time. We want to know what the categories are so you can organize your page and show all the drinks together, all the salads together. We want to have the locations. We want to have the fulfillments. There's a whole bunch of things that you can add onto what you're getting in the response. And it's not just data that you're adding to return. You want to be able to filter and ask questions on the aggregate of all that data. So you want to be able to ask, like, if I order for 5 p.m., what will be available for pickup at the location near the train station that is under $20 or something? So we started from something pretty simple. We want a list of products, and we got something much more rich and complex by the end. If we look at the clients for this app, they are pretty much all around the world. Square is present in multiple continents. And they're, for the majority, mobile users, but there's still a good portion of desktop. All right, I said scale. What are the numbers for this app? Every day, it handles hundreds of millions of requests. We're not quite there yet, but we're getting close to running 1 billion jobs per day. It has had over 300 contributors over time, 60,000 commits, over 10,000 PRs, et cetera. So how are we going to scale things? Well, if we look at this black box as being the capacity we have on the back end, and the requests being the blue disks, we have a couple options for how we scale. The first one is we can go for performance, make each request more performant so that we can fit more of them within the same capacity. If we can't do that, maybe we can purchase more capacity, get a bigger server, get more servers, fit more requests in the same way. The third option, which is always very interesting, is maybe you can figure out that your API are not really tailored to what your app is doing. And you can shift how you're doing things to keep providing the same value to your customers while doing less. So, story time. I'm going to tell you about a couple obstacles we encountered as we were scaling to where we are today, and what we did to overcome each and every one of those. And we start, I think 6 or 7 years ago. The app was pretty small. We get in the office one day, and our latency graph looked like this. It had gone up by 50% or something. What had happened is we had finally enabled secure TLS connection to our database from the app server. And we don't connect to a single database. We have 3 or 4 that we need to connect to on every request. And TLS connection take a bunch of time to get set up, which meant we had a huge and increased latency because in PHP, if you're running with FPM, as most of us are, at the end of every request, everything gets trashed away, and your connection is no longer there for the next request. The solution to that is available and has been available in PHP for a long time. It's not set up by default for Laravel or for any PHP framework that I know of. But it's to set up persistent connections. So you can tell PHP, when you're done with my request, you clean up everything, but not that connection. That is important to me. I want to keep it around. So there's 2 attributes that we set on most of our connections. Suggest you play with them, figure out which ones are right for you or not. The first one is setting up persistent connection. The second one is emulating the prepared statements. What that does is PDO, the SQL library in PHP, will run the prepared statements in memory in the app instead of you having to go to the database server and do a round trip and add the load on the database server for it to do the prepared statement. So you can get rid of that. And with that, we're back to normal. We're happy, and we can move on. Next thing that happened is, I told you about how we include data, additional data on each and every entity that we return through the API. That worked extremely well when we had a single entity to return, and we had a very classic N+1 query problems when we were returning potentially hundreds of items in a single response. So eager loading is obviously available in Laravel, but the library we're using to serialize and build our response in JSON is called Fractal. It's not aware of Laravel. So we had to build a bit of a shim to let Fractal know, hey, when we're requesting to include the options, it's just a very easy, this is the Laravel thing we're trying to eager load. Just go on the model, go through the entire collection, load all of the options for all of them. And again, obstacle avoided, and we kept going. All right. At that point in time, this would have been a typical distribution of the latencies of our requests. So nothing was extremely fast. I think the fastest we had was around 50 or 60 milliseconds. The peak might have been around 150, and then it goes as slow as you can get as a long tail of requests. We wanted to improve that by adding a bit of caching. And our goal for caching, well, we had 3 main goals. The first one was, as much as possible, if we can avoid talking to the database at all, cache at the very first layer, only talk to the cache and return, then that's what we want to do. The second goal was that we didn't want to just cache for a set amount of time, maybe 60 seconds or something. No, we wanted to cache for as long as the data was valid. And the third goal was that we wanted to have partial caching. If we didn't have the entire response, we wanted to fall back on some parts of the response would still be pre-computed. So if we look at what's being put in the cache at that point, at the very top level, we have the whole response with the entities that are going to be returned. And then we have each of the entities, and they're composed, again, of directly models from Laravel. That will be the items, the discounts, the locations. And we want to be able to cache at each and every one of those layers because each and every one of those layers takes some time to compute and might do additional requests or anything. So we want to cache everywhere we can. Sorry. What that means is we have cached values that encapsulate each other. And if the price for the egg toppings, for example, were to change, we want to be able to clear out of the cache an entire branch of the tree of things that were put in the cache. The way we started working on that was using Laravel's cache tags. So for each model, we would assign a tag, and the tag was based basically on the model class. Is it an item? Is it an option? And its unique ID. At the layer above, we would collect the tags from below and apply them to the values there. At the top level, we would collect all the tags from the entire tree of objects in the response and have them all applied to that top value. And what that means is when the price of the egg toppings for your salad changes, you know that it's the red tag. You can tell Laravel, clear anything related to that tag, and it would clear exactly, we can see the branch of values that we had earlier. Now, we had two problems working with that when we tried using Laravel's tags. The first one is the way you use them, you call cache, call const tag, you give the name of your tag, you put a key, you put the value, no problems here. But when you want to retrieve something out of your cache, if you're using the memcached implementation for this cache tag at least, you have to be able to provide the tag as well as the key. That does not work for us because when you're at the top level, the only thing you know about is the URL. You're trying to get something based on that. You don't have access to all the tags. The only way to access all the tags would be to recompute the entirety of the response, which is kind of defeating the entire point. The other issue we had was whenever you call to retrieve a value that is tagged, you make a first call to get the most recent tag hash, and then a separate call to your cache server to get the value. And if you have free tags, you make 3 separate calls for each of the tags, and then 1 for the value. And so with my first iteration of this, I had successfully replaced a system that did 10 database queries with one that did 700 cache queries, therefore improving the speed of our response by negative 5,000%. Yes. So today we've built a library that is open source that helps us work with this exact problem. It allows you to have a huge amount of tags on your values. It allows propagating the tags for you across a large number of values that encapsulate each other. And most importantly, it makes sure it only does 2 calls to your caching server ever to retrieve everything. Once everything was in cache, we moved from the latency graph that is up top to the one at the bottom. So over a period of time, if we put every request of a given latency in a bucket, things shift tremendously to the left where they're extremely fast. And after that, you find a second distribution that kind of mimics the one you had before. OK. Next up, I've shown you this nice graph so far of things like scaling nicely over time. The reality for us at that point in time looked like this. This is around March 2020. There's lockdowns everywhere. And all our merchants, all our customers that used to do business in person at their own store saw everything shift to online, and we had a demand that exploded over a couple of months. So over that time, there's a couple of things we did. We definitely added servers and added capacity to our data center, but at the same time, we also absolutely had to reduce how much traffic and how many requests we were handling. The first thing we realized is because those online stores are all front-end applications, they were receiving mostly an empty HTML in the beginning. And then we had worked on all those includes to get them all the data at once. But there's a lot of other things that they needed ahead of time. What they needed is to know, like, are there even multiple locations in there? Do you allow for pickup and delivery? Should I offer that choice to the person who's coming in to buy something or not? But they had to know a lot of settings and aggregate information about the store before they could decide what they were going to show to the person coming in to buy something. What we did is change things a little bit, built API for just that, returning them the settings, putting them in the HTML from the beginning, so that we could avoid a lot of the back and forth requests that were happening before we would even show anything to the person coming to the site. I remember very clearly going from 1 week to the next where we had almost halved the number of requests that we had to handle. The other thing we did at that time is we realized if we don't have enough servers to handle the load, well, we can use other people's servers. And what that looked like for us was realizing everything that we return in this API is going to end up on a public website in HTML. Sure, we're transferring it in JSON. That's just a different format. Anyone can see everything in there. There's no authentication. There's no authorization on any of that. That means we could use CDNs to cache our APIs. And when you do that, your user is going to connect to a node very close to them. If they're going for a restaurant in New York, they'll have a CDN node in New York that they're connecting to. And if the data is there, they'll get it directly from the CDN. If it's not, they'll go back to our server and fetch it. And the caching strategy we used earlier with the tags, we could apply directly with our CDN provider as well. Sorry. So that we could say, hey, every single response I have ever sent back that was about the tacos, move them from all of your nodes everywhere across the surface of the earth. So different CDN providers will have different ways to do that. For us, it's through passing a couple of specific headers. The first one is surrogate control. It's a cache control header that will apply only to our CDN provider and nobody else. So we say cache things for up to a year. And the second one is surrogate key, where we can pass a list of additional keys. Usually for a CDN, you're going to have one key. It's going to be the URL at which things were accessed, and that's where the value is going to be stored. With this, you can pass as many additional, not as many, you can pass a few hundred additional keys that the CDN will tag your cached value with, and whenever the price of the tacos is changing, you can remove that. You make an API call to your CDN provider to remove anything that was ever about the tacos. Okay. So over time, as we added more and more features, as we added things like scheduled fulfillment and scheduled availability that played with time and everything, our latency distribution looked more like this and like this. And sure, when things were cached in the CDN, you would get all your information in 20 milliseconds, inclusive of the round trip. Incredible. If you were one of our most complex or more sophisticated merchants, it didn't look so good. It could take up to 20 seconds for you to get anything to show on your page. Problem was, like I said, we had all these entities, and we want to be able to query and ask questions on the aggregate of the locations, the fulfillment, the item, the inventory, and everything. So there were dozens of tables from our MySQL database that were involved in deciding what do we even return in the response. And it's pretty impressive that we were able to build those queries. When we saw them for the first time, because our teams that were monitoring the database were telling us, what is this query? It's 200 lines long. And we're like, I have no idea. I don't know who built that or where. So Eloquent allows you to build very complex queries very easily. You can add an if statement here with a subquery, an if statement there with a has query. But at this point, that was not working anymore. What we went for is we decided that instead of going to MySQL every single time that a request was coming in and recomputing everything from scratch, what we would do is every time something would change, we would trigger background job, recompute the data for that item, put it in an Elasticsearch index, and that index is specifically designed for exactly the kind of questions and queries that our online stores are going to ask of the API. What's available at that time under this price? Those kind of queries. It sounds incredibly easy when you say it like that. No, we just had things in MySQL, we put them in Elasticsearch. The reality is, like, you have an API that's already handling tens of millions of requests a day at that time. You're trying to swap out the engine. You want to make sure that both versions work exactly the same so that you're not breaking anybody's business. So it took between 6 months and a year to get there. But the results we got in the end were that we went from 20 seconds on average for our most complex users to 200 milliseconds, which this time was a very valid improvement for us. Okay. At some point, you'll start having more services that you have to talk to. And when you have a service-to-service call on your backend, if we look a little bit at what's going on within that call, we go back to the same problem we had with our database connections in the beginning. The first thing you're doing is you're always setting a new TLS connection. And then if the remote service you're talking to happens to be a PHP service or a Laravel service, well, it will have some amount of initialization time on every single request, and then the actual work you care about. Now, if you're lucky and you're starting today, you want to use Octane. Because Octane will keep everything running from one request to the next. On the first service, you don't have to pay the price of setting up a TLS connection. You have your HTTP client that you've kept around from one request to the next. On the remote service that you're calling, because it's also kept running, you don't have to pay the initialization cost of your framework every single time. Unfortunately for us, just changing our apps that had been built on PHP FPM for years already to use Octane was not really an option. So the next best thing we found was to use Envoy. Envoy is a huge, massive, and incredibly complex project. And we don't care about any of that for the most part. What we care about is that Envoy is a forward proxy. And if it's a forward proxy, it can keep a connection pool for us and avoid the cost of setting up TLS connections every time. In practice, what that looks like is we have our pod with our PHP processes running. And whenever they need to make a call to a remote service, they'll first go through Envoy that is running on the same pod. And Envoy has pre-established pools of connections to that remote service. It'll grab the request that the PHP process is trying to push through, put it on one of those connections, return the response, and you save a ton of time that way. OK. Before we finish, I want to talk a little bit about scaling with jobs. The bigger our apps have scaled, the more jobs we've been running to pre-compute information, to have things ready ahead of time, to send SMS or emails or whatever. And the first thing I want to acknowledge is that Laravel makes it incredibly easy to set up jobs. You can start by having them on your database, move them to Redis, move them to something like RabbitMQ or SQS. We've moved queues that did over 100 million messages per day from RabbitMQ to SQS with zero downtime. And it took an hour to figure out the code. It takes a bit longer to deploy everything when it's a bit high risk like that. But it's extremely easy. And when I see other teams that I work with at the company, when they work in a different ecosystem, this is all stuff that they have to either custom build or bring in new dependencies for. If you're using Laravel, all of that stuff is there for you out of the box. I want to touch on 4 interesting queuing patterns that we use to be able to keep things smooth in our operations. The first one is deduplication. It was not available in the version of Laravel that we were at when we first needed this. But it's the idea that if your queue happens to be a little bit backed up, and somebody is updating the data very fast, they might put 20 jobs on the queue that are all for doing the same thing. And if you already had one job representing that work, there's really no need to do the other 20 ones after that. So deduplication is a technique where you assign a specific ID to each and every job representing the work to be done. Whenever Laravel detects that this is already on the queue and hasn't been worked on yet, it will skip queuing the message. You end up with much smaller queues. And we had queues where we would be woken up at night or on call over the weekend because we were getting close to 1 million messages that were not processed. And after doing things like that, they rarely get over 10, 20,000 messages. Incredibly useful. Another one we use that is also today available in Laravel is the idea of workflows. We have a team that spent years building their own workflow engine in Laravel, and now we use the one from Laravel, and it's the idea that you can have batches of jobs that can run in parallel, but at the end of all of those jobs, you want to regroup and trigger the next step or the one after. In Laravel, they're called chains and batches, and you can combine them in absolutely any crazy way you want. And again, when we look at other teams and other ecosystems that are in use within Square, whenever they want to do something like that, it's something where they have to pull a brand new dependency to do stateful workflow management for them. If you're using Laravel, this is free. It's included in the package. The next 2 ones are not in Laravel, and I'm not going to contribute them to Laravel until I figure out a way less gnarly interface to using them than what we have internally. The first one is buffering. You can imagine if you're talking to an API where you might get rate limited, it might be better to send things 10 by 10 instead of sending them 1 by 1. So we have a queue worker that will grab messages as they come, bundle them up, and it will wait until one or two of two conditions apply. Either we got to the max number of messages we want to have, or we've waited for 10 or 20 seconds, and we haven't reached that level yet, but we still want to send the message. At that point in time, it will bundle all of those together, put them on a separate queue where they get worked on. Working with providers that might have rate limits but offer batch APIs, this is again something that has proved very useful to us. All right, final one. This is my absolute favorite one, and it's the notion of fairness. So because we moved to a system where we have to index things and put them in an index before anything shows up in your online store, there can be a little bit of delay sometime before things are present. And if you imagine the lady in green over there working for one of your most complex customers, and I don't know, it's Sunday night, they're updating their entire catalog to get ready for the week. They're pushing for us hundreds of thousands of jobs to the queues. And because they're a more complex customer, each and every one of those jobs also takes way longer than it takes for everybody else. So they're hogging the queue just for themselves at this point in time, and Mr. Blue behind is just trying to get set up for the first time. He made a typo on the product that he's trying to sell, and nothing is updating. And he's been there for 30 minutes, and he's wondering at which point he's going to start to call us and scream at us that we're really not doing our job. So what we did for that is we worked with Laravel's rate limiter, and we made an update to it so that instead of incrementing only by 1 every time you call it, you can increment it by custom amount. And with that, every time we run a job for any of our customers, we're going to count how many milliseconds it took to run that job, and we're going to increment the rate limit for that customer and that type of job by however long it took to run the entire job. With that, if they get too many jobs or if their jobs are taking too long and they trip the rate limit for the next 20 minutes, every single job that comes for that specific customer will be shifted to a separate queue that has a separate pool of workers. Their stuff will get worked on slowly, nicely. They're not in a rush. They know they made a big update, but everybody else is still being processed through the main queue with a dedicated pool of workers. Their stuff stays nice and snappy, and everybody's happy again. All right. That's the end of today's talk for me. It's not the end of our challenges in scaling with Laravel. If you found any of those interesting, if this is the stuff you'd like to work on, I think we still have open positions. Some of them are even to work with Laravel. Otherwise, there's plenty of those at Square. Thank you.
Nicely done.
Hey.
I love seeing the sigh of relief after a speaker finishes. At the beginning, you put up some truly insane numbers of jobs, requests, et cetera. How big is the Laravel team inside of the Square organization?
So it's only the online store folks that use Laravel. We have, I think, 15 apps. 3 of them are large on the same scale, the other not as much. And I think we have between 70 and 100 engineers working in Laravel.
That's awesome.
I'm not sure. It used to be more.
Hey,
I think that's where we are.
If that's directionally correct, that's great. My second question is, you put up a lot of things that seem like they have like formal study that has been done upon them, specifically like the queue patterns and all of that stuff. How did you learn that, and what would you recommend for us if we want to dive into like the different types of queuings, the different types of caches? Did you just learn that on the job, or is there some material?
I kind of winged it.
Okay, that's what we like to hear. Yeah, absolutely. Okay, well, for the rest of us, hopefully we're as smart as Seb, which I very much doubt. Seb, thank you very much.
Thank you so
done.
much.
Good job.
Thank you, everyone.